Hello, I'm Mrs. J, and today we're going to finish the second half of 13.3 and 4, which was working with the second derivative. In economics, the second derivative, the inflection point, is called the point of diminishing return. It's the point where a profit or revenue begins to get more difficult to increase. It's the point where you probably can't come back from. So finding the point of diminishing return, we take the derivative twice to find the point of inflection. So taking the derivative the first time, we get a negative 3x squared, that just goes to 0, plus 84x plus 800. Then we take the derivative again, because this one gets our critical numbers, this gets the point of inflection. Negative 6x plus 84. So that's our second derivative. We want to set that equal to 0 and solve. Negative 6x equals a negative 84. Divide by that negative 6, and you get 14. So 14 is the quantity for the point of diminishing return, but you still need the point. It's a point, you need the y value. To find it, you plug it into the original, which was 10,000 minus 14 cubed plus 42 times 14 squared plus 800 times 14. And when you calculate that, you get 26,688. So the point of diminishing return is 14,26688. So the biggest thing is once you take that second derivative and set it equal to 0, to remember to plug this into the original. Okay. Sketching the curve, finding domain, critical numbers, point of inflection. This one just covers a little bit of everything. But we could look at the graph first if you want. You plug this into your function and then graph it. You're going to get this. Looks like that. And you can see that there's a high point here, so there's probably a critical number there, and the concavity changes here, so there's point of inflection. To find those, we need to take the derivative. Product rule, first times the derivative of the second. Derivative of e to the negative x is e to the negative x times the derivative of the exponent, which is negative 1, plus the second times the derivative of the first. So that's our first derivative. I'm going to simplify it because we need to take the derivative again. We get that. Now, we're going to set this equal to 0 and solve. You could divide by e to the negative x, because e to the negative x will never equal 0. And we get a negative x plus 1 equals 0. Bring the x over. This is a critical number. So this high point is at 1. To find the critical point, we'll plug it into the equation. And when you plug it in, you get 0.368. So I don't think I plugged this one in here yet. X. The e to the x is down here, right here. And we want a negative x. My window, -2, 5, negative 4, 2. And there's our graph. So to find the critical point, we go to Table, I'll delete these, and plug in a 1. We have the 0.368. To find critical point of inflection, this would be all real numbers because there's no fractions, there's no square roots, and there's no logs. So x is a member of all real numbers for the domain. But you can also tell from the graph it's covering all of the x values. The second derivative, this has a product rule. First times the derivative of the second plus the second times the derivative of the first. So all of this is just this first one. Then we take the derivative of this, which is e to the negative x times a negative 1. So all of that would be the derivative. Whoops, we're going to set it equal to 0. This negative times this negative just makes this positive. So it's a positive 1. Minus e to the negative x and minus e. Oops. You could add those, but we'll just leave it separate. Four terms, we can divide them all by the e to the negative x. And we get x minus 1 equals 0, x minus 2, which gives us 2 for the x value of the point of inflection. To find the y value, we'll plug it into our table. 0.271. So that's our point of inflection. The x and y intercept is at the origin, but if you wanted to find them or needed to find them, the y intercept is when x is 0. So if we take the original and plug in 0, we get 0, because 0 times anything is 0. And when you have this, the origin for your y-intercept, it's also your x-intercept. X-intercept is when y is 0. So if we set this equal to 0, oops, x. We know that e to the negative x can never equal 0, so we can divide by it, which means 0 is x. So it's just giving you the same thing. If the origin is your x-intercept, it's also the y-intercept. That's all we needed to look for. So you would need to go through all these steps, but we use the calculator for most of our graphing. But you do need to be able to find the critical point and the point of inflection.